Welcome to the Bentley Systems training course, where we will discuss topics about how to push a RAM structural system building model to the iTwin Analytical Synchronizer using the local file workflow. In this particular video, we will review the steel members in our newly created iTwin repository. Let's first review the curved member objects in the iTwin repository. So in the Objects window, we'll go ahead and scroll down and we'll find our curved member objects. Now this will include all of the piles, columns, beams, and braces that exist in your model. We're going to focus our attention on the steel members, and we can do this by using the View tools in the ribbon toolbar. So if I were to take a look at this levels area, I can see that all levels are currently visible. If I was interested in only taking a look at the steel levels, I can turn off the other levels for simplicity. In addition to that, I could take a look at each of these levels and decide if there are certain aspects that I don't care to see at this present moment. Now within the View window, we've gone ahead and isolated the model so we're seeing just the steel system. If we want to further isolate the items that we can see within the Objects window, we can go ahead and use some of those filter tools that are available. So here in the Objects window, we can isolate our view just to the curved members. And we can isolate that to just our steel system. Now RAM structural system beams, columns, and braces are pushed to the iTwin Analytical Synchronizer as curved member objects. Each curved member object will have a series of properties assigned to them, which you can see in the Properties window when any particular member is selected. Let's go ahead and take a closer look at a few of these properties and their significance on when you push or pull a model from the iTwin Analytical Synchronizer into RAM structural system. So the first field I'm going to take a look at is the load resistance field. This will indicate the framing property that's assigned to each member in the RAM modeler. Let's go ahead and scroll on down to find our curved member properties. Now here we can see for the currently selected member that a camber was assigned to this steel beam in the RAM steel beam module, and that information will be pushed to the iTwin repository. In addition to that, we're going to go ahead and find our system kind field. Now this will indicate the type of material that was used to model the member in RAM structural system, either steel, concrete, steel joists, or other. Next, let's take a look at the use field. Now this indicates the member type in RAM structural system, and it'll either be indicated as a beam, a column, a vertical brace, or a horizontal brace when we're talking about steel members. Next, let's go to the member end fixity. Now this will indicate the member end fixity assigned to the lateral members in RAM structural system. And let's go ahead and select one of our moment frame beams so we can see how that looks in your iTwin repository. Here you can see that the beam member that I've selected is part of a moment frame, and the member ends have been fixed in the RAM modeler. Let's go ahead and scroll down a little bit more, and then we're going to see our reactions at the ends of the members. Now in RAM structural system, the reactions due to gravity loads are calculated in the RAM steel beam module. The beam end reactions due to the gravity loads only can be pushed to the iTwin Analytical Synchronizer as either service reactions or factored reactions, depending upon your push settings that you specified when creating this repository. Next, let's go on down and take a look at some of the related items. Now, related items indicate properties that are assigned to this member that have additional information in another area of your repository. So here we're going to see that the material properties and section properties are both indicated here. For the material properties, a yield strength of steel was assigned to each member when it was modeled in RAM Structural System. Now here I'm going to see that the material for the currently selected member is available, and if I select this material, it will show me the additional information that is used to define that material, including the yield strength of steel. In addition to that, I'll also be able to see the section properties that were assigned. Now in RAM Structural Systems, steel section properties are defined in the Master Steel Table and the Master Steel Joist Table. The steel section properties will be pushed to the iTwin Analytical Synchronizer as table section properties. And if I wanted some additional information, I can click on any of these sections and I'd be able to see the specific properties that are defined for that section. Let's go ahead and scroll on down, and we will find our composite stud information. Now in RAM Structural System, shear studs on composite beams are designed in the RAM Steel Beam module. The stud configuration will be pushed to the iTwin Analytical Synchronizer as a shear stud zone. So let's go ahead and select on this as well, and I'd be able to get some additional information regarding the shear stud layout and properties that were assigned to that beam. The last thing we're going to take a look at is any custom properties that were assigned to this member. This would include things like hanger information, cantilever information, and deflection properties. At this point, this concludes our process for reviewing our steel members that were pushed from RAM Structural System to the iTwin Analytical Synchronizer. Hopefully, by exploring how this information is pushed to the iTwin Analytical Synchronizer, you will better understand how a model will be also pulled into RAM Structural System from iTwin, and understanding which fields will define different pieces of information for those specific members.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.